Let's talk about how to perform and describe reflections, which is basically turning a figure over a line. So we're going to have to know how to graph lines in order to perform a reflection. So take a quick second to complete this warm-up. Graph each of these 3 lines. Pause the video and try it now. Well, y equals 2, that would be a horizontal line. That's like saying every single point that has a y value of 2, connect them all. And that would be this line. Whereas x equals 3 is saying every single point that has an x value of -3, connect those points. And that creates this line. The line y equals x is all of the points for which the x value and the y value are the same thing. Like 0, 0, 1, 1, 3, 3, -5, -5. All of these points have the same x and y values. You can also think about it like it's in slope-intercept form, y equals mx plus b. M is the number that's in front of x, and since there's no number in front of x, you can assume it's a 1. So my line has a slope of 1. And b is whatever you add or subtract from x, but you're not adding or subtracting anything, so that must be 0. And that's where you start on the y-axis. So 0, 0 is my y-intercept, and I have a slope of 1, so up 1 and over 1. It's important that you know how to graph each of these types of lines for what we're doing today with reflections, because sometimes we're going to reflect over horizontal lines, which are y equals a number types of equations. And sometimes we'll reflect over vertical lines, which is x equals a number, and sometimes we'll reflect over the line y equals x, which is this diagonal line right here. First, let's talk about the formal definition of what it means to reflect. In order to reflect, you always have a line of reflection. That's the line that you're going to reflect over. And if the points that were reflected are connected, the pre-image point is connected to the image point, the line that connects those 2 points will always be perpendicular to the line of reflection. And the line of reflection will always be the segment bisector of the line that connects the pre-image and the image points. Let me show you what I mean. Here we have pre-image segment AB, and image segment A'B'. Segment AB was reflected over the y-axis. So if I were to connect the pre-image point of A to the image point A' and connect them with a line, this line is perpendicular to the line of reflection. And the line of reflection cuts A' in half. This little part of the segment from A to the line of reflection is the same length as it is from A' to the line of reflection. And we could show that the same thing is true for B and B'. And this general idea is what we're going to use to perform reflections. The first thing you should do every time you're asked to perform a reflection is highlight what your line of reflection is supposed to be. In this case, we're going to reflect in the y-axis, which is the vertical axis. So I'm going to go ahead and highlight that in purple. To get from the pre-image to the image, I need to count from each pre-image point to the line of reflection, and then count that far away again on the other side of the line of reflection. So for example, from C to the line of reflection, I go to the left 2. So to get from the line of reflection to C', I'll go left 2 more, and put my point for C'. So C' has the coordinates -2, -5. Let's do the same thing for D. From D to the line of reflection, we go 8 units to the left. So to get from the line of reflection to D', we go 8 more units to the left, and put the point for D'. D' then is the point -8, +4. And you can connect those 2 points with a line to complete the reflection. These are the coordinates of the image. If we had written the coordinates of the pre-image, you would see that they're the exact same numbers, except the x values have opposite signs. C is the point +2, -5, and C' was the point -2, -5. D is the point +8, +4, and D' was the point -8, +4. So when you're reflecting over the y-axis, the y values will stay the same. See how D and D' are lined up horizontally, and C and C' are lined up horizontally? The only thing that changes is the sign of the x values. Instead of going to the right 2 to get to C, I go to the left 2 to get to C'. Let's try another one. This time we're going to reflect in the x-axis, so let's highlight that. And we need to count from each pre-image point to the line of reflection, and then count that far again on the other side of the line of reflection. So for example, from E to the line of reflection, I go down 3. So I'll go down 3 more to get to E prime, which is the point -8, -3. From F to the line of reflection, I go down 7. So I'll go 7 more down to get to F prime, which is the point -4, -7. And G, I also go down 3, and I go down 3 more, and there is G prime. So this time, if you look at the coordinates of the pre-image and compare them to the coordinates of the image, you'll see that again they have all the same numbers, but the signs are slightly different. If you reflect in the x-axis, the sign of the x values stay the same, but the sign of the y value changes. For example, E was the point -8, +3. But E prime was the point -8, -3. So they both had -8. For both of them, I went to the left 8, but to get to E, I went up 3. To get to E prime, I went down 3. And the same could be said about F and F prime and G prime. So that's an alternative way of finding the coordinates of the image, is instead of counting from each point to the line of reflection, you can just change the sign of either X or Y depending on which axis you're reflecting in. Let's try another one. We'll be reflecting in the y-axis, which is the vertical axis right there. So to get from H to the line of reflection, I go to the right 3. So I'll go right 3 more and put my point for H prime. That's the point 3, 6. Which makes sense for H prime to have an x-coordinate of +3, because H, the pre-image coordinate, had a -3 for its x value. Let's try I. Well, hold on a second. I is on the line of reflection. So how do I get from I to the line of reflection? I don't do anything. I is just going to stay I. If you have a point on the line of reflection, it doesn't go anywhere. It just stays exactly where it is. And last we'll do J. From J to the line of reflection, you add 8, or you move to the right 8. So you go 8 more to the right to get to J prime, which is the point 8, -6. So this is the image of triangle HIJ after reflecting in the y-axis. Let's try another y-axis one, but this one might look a little bit strange. Let's take a look. From K to the line of reflection, I go to the left 5, so I'll go left 5 more to get to K prime. And for L, I go to the left 9, so I'll go left 9 more to get to L prime. Everything's been pretty normal so far, what we would have expected to see based on what we've seen on the other examples. I went to the left, to the left, to the left, to the left, but M is on the left-hand side of the line of reflection. So I don't want to go left to get to the line of reflection, I need to go the opposite direction, which means going to the right. So I'll go right 2 and then right 2 more, and that gets me to M prime. Sometimes you'll see situations like this where the pre-image and the image end up overlapping. And that's totally normal. If the line of reflection passes through the figure, then you're going to end up having to go both directions to get from each point to the line of reflection and beyond. Next up, we're going to reflect in the line y equals 4. Remember, y equals equations are horizontal lines. It's like saying find every single point on this plane that has a y value of 4, like this one and 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 this one. This is the line y equals 4. So instead of going from N to the x-axis, I'm going from N to this line of reflection. So from N to the line of reflection, I go down 3, so I'll go down 3 more to get to N prime. Be sure when you're counting the coordinates of your image vertices that you count still from the origin. A common mistake is to make this the new origin, the intersection of the axis with the line of reflection. Don't do that. The origin is still the origin. That's still how we identify the coordinates of points. So N prime would be the point -4, +1, because you go to the left 4 and up 1 from the origin. So let's figure out the coordinates of O prime. From O to the line of reflection, I go down 5, so I'll go down 5 more to get to O prime. O prime is the point 6, -1. And P, we go down 2, so I'll go down 2 more. Here's P prime, the point 8, 2. So this is the image of triangle NOP after being reflected in the line y equals 4. This time we're going to reflect in the line x equals 3, and x equals equations are always vertical lines. It's like saying find all of the points whose x value is 3, and that's all of the points on this line. You'll notice that our line of reflection passes through the figure this time, and that's totally normal. It's totally fine. You will have to go to the left for some of these points and to the right for some of the other ones to figure out how to count from the pre-image to the line of reflection and from the line of reflection to the image coordinates, and that's fine. And it will mean that our image and our pre-image overlap each other, and again, that's totally fine. So here we go. Going from Q to the line of reflection, I go to the right 3. So I'll go to the right 3 more and put Q prime. Q prime is the point 6, 3. Again, make sure you're counting from the origin when identifying the coordinates of your vertex. I go to the right 6 and up 3, so Q prime is the point 6, 3. So I went to the right to get from Q to the line of reflection and from the line of reflection to Q prime, but now I need to go to the left to get from R to the line of reflection, and then from the line of reflection to R prime. So R prime is the point -1, +8, and S, I go to the left 3, go to the left 3 more, and I get S prime as the coordinates 0, -7. So this triangle is the image after reflecting the triangle RQS in the line x equals 3. Let's try reflecting in a not horizontal or vertical line. Let's reflect in the line y equals x, which you might remember we talked about on the warm-up. It looks like this purple line that you see on the screen. And remember that the formal definition of reflection is that you have to count perpendicular to the line of reflection. Well, counting perpendicular is kind of challenging in this case because it's not just horizontal or vertical. So instead, we can do a combination of horizontal and vertical movements to end up doing the same thing. Or, an easier way to think about this, instead of counting in this situation, the line of reflection actually tells you what to do to your points. It means make y your x and make x your y. T was the points -8, +2. So I'll just switch those around and make my y my x and my x my y. So the coordinates of t prime must be 2, -8. Same idea with u. U is the point 1, 5. But I need to switch that around because y is x and x is y. So u prime must be the point 5, 1, which is right here. The other way that you can do that if you don't feel comfortable switching around your coordinates like that is by counting horizontally and vertically. So from T, horizontally to the line of reflection, I go to the right 10. So then I need to go vertically the opposite direction. So I'll go down 10, and that takes me to T prime. So from U to the line of reflection, I go to the right 4, and then from the line of reflection, I'll go down 4 to get to U prime. As you can see, you end up with the same image coordinates either way, so it doesn't matter to me which way you do it. Let's try another one. Again, we're going to reflect in the line y equals x, and there's two ways that we could go about doing this. You could just write down each of our pre-image coordinates. V is the point -6, +1, so V prime must be the flip-flop of that, because y is x and x is y. So V prime would be 1, -6, which is this point right here. W is the point -2, +9. Switch that around to make W prime, and I get 9, -2. And X is the point 2, 4. Switch that around, and you get the point 4, 2 for X prime. So here is the image of triangle VWX after being reflected in the line y equals x. Alternatively, you can count horizontally and then vertically from each pre-image point to the line of reflection and beyond. For example, V to the line of reflection is 7 units to the right, so then I can go 7 units down to get to V prime. W is 11 units to the right to get to the line of reflection, and then beyond that I go 11 units down to get to W prime, and X would be 2 and 2. For our last few examples, let's switch it around. I'm going to show you a completed reflection, and you're going to tell me what line it was reflected in. The easiest way to figure this out is to pick two corresponding points, like A and A prime, and count the distance between them. A to A prime is a total of 14 units. Well, we know that the line of reflection is halfway in between the pre-image and the image. Half of 14 is 7. So counting from the pre-image point and the image point inward, 7 units each, we find out that the line of reflection here must be the y-axis. Let's try that again. Pick two corresponding points, like D and D prime, and figure out how far apart they are. From D to D prime is 6 units. Well, we know that the line of reflection has to be halfway in between the pre-image and the image coordinates, so half of 6 is 3. So if I count 3 inwards from D and D prime, I find out that this is the line of reflection. It's not the axis. It's, in this case, x equals 1. Remember that vertical lines are always x equals, because all of the points on this line have an x value of 1. So triangle DEF was reflected in the line x equals 1 to create triangle D prime, E prime, F prime. I know that this next reflection looks kind of scary because it's all on top of each other, but again, just pick 2 corresponding points, like I and I prime, or G and G prime, or H and H prime, and count the distance between them. From I to I prime is 10 units, and half of 10 is 5. So if I count 5 inwards from I and from I prime, I find out that the x-axis is the line of reflection, because it's the halfway point between the pre-image and the image. On our last example, it's a little bit different. It's going to start out the same though, that we count from one coordinate to its corresponding coordinate, but the problem is it's a little bit harder to count because it's diagonal. So whether you're talking about from K to K prime, or L to L prime, or J to J prime, each of those lines was diagonal. And honestly, for this class, for geometry, we're limiting our reflections to being reflected either in horizontal or vertical lines, which is obviously not what we have here, or reflecting in the line y equals x. So since I have diagonal lines, I must have been reflecting in the line y equals x. And you can actually see that that is the halfway point if you count like 2 diagonal units between j prime and the line of reflection, and also 2 diagonal units between j and the line of reflection. So you can confirm that this is the line of reflection, y equals x. And that's all you need to know about how to perform and describe reflections. In our next lesson, we're going to learn how to perform and describe rotations.